Now that we've drawn a simple Lewis structure, actually I'm going to bring that Lewis structure back here in a minute. I want to talk about this idea of resonance structures. Resonance structures, like I said, are kind of sister structures. They have the same atoms, okay, and arranged the same way, but where the lone pair electrons are swung from, and then related to that, where there is a pi bond, it's different. Remember a minute ago when I actually, on the example, I swung from the, what was it, the east oxygen, but on my next slide I had swung from the north oxygen, lone pair electrons in to make a pi bond. Those were resonance structures. So it's just a matter of swinging. Resonance structures actually allow for this kind of cool, sort of really stable situation where electrons, I kind of think of like if you have a shoulder and you dislocate your shoulder's kind of floating around in there. Okay, I know it's not the same thing, but electrons can become what we call delocalized with this phenomenon of having very possible similar resonance structures. So resonance structures can be thought of, if they are both valid, or kind of, how do I say this? I don't know if I like this analogy. We can kind of think of two mythical things. These are our two possible resonance structures. And what Mother Nature does, or what really happens, is the delocalization of electrons, like I said a minute ago. What really happens is something kind of neither this nor that. Okay, this is something kind of more real. I don't know if I like that. So these are the two resonance structures of the formate ion. This one actually was the one that we kind of saw on the final slide. This one was the one that actually I kind of created prior to that. Notice that here we swung electrons this way, and here we swung electrons this way. Are they both very valid? Yeah, I buy either one of them. Okay, but kind of probably what's happening is something kind of in between. So the in between would be this one, where we basically have electrons delocalized, and it's been a while since I've done much with it, but they kind of go back and forth between both of these possible resonance structures. Okay, so in physical science or in chemistry, you kind of saw these two-way arrows. That just simply means that we usually talk about that as being kind of an equilibrium situation. It kind of goes back and forth between those two possible structures.